Okay, we're going to wrap up an example from yesterday, and then we're going to talk about imaginary numbers. Okay, boys and girls, eyes up here. So what we have is we have a polynomial of fifth degree, and so every once in a while you got to stop and smell the roses and kind of see where you've been and enjoy life. So just think about it. If you were given a fifth degree polynomial, uh, at the beginning of say freshman year, you would have no idea what to do with it, right? No idea. And yet we're going to find all 5 solutions, and we're going to be able to graph it within a matter of about 3-4 minutes. And so the fact that you can do that, you can be that efficient, that effective, it's pretty cool. So let's go to work. The degree is 5, so therefore it has how many solutions? 5 solutions. So I'm going to list the number of positive real, number of negative real. Positive real, I look at P of X, I look for what? What am I looking for? Changes in the sign. Okay? How many sign changes do you see here? There are 4. If you start with the x to 5th, that's positive, then a negative, negative to positive, positive to negative, negative to positive. So that's a total of 4. So therefore, you have 4 or 0. So it might have 4 positive real solutions, but it might also have some complex solutions or imaginary solutions. If it has complex imaginary solutions, then those come in pairs. So we reduce it by 2 each time. So it could have 2 of them, it could have 4 of them. Now, let's look at the negative real solutions. How do I check that? We have negative x, and as Kayla says, I change the odd powers switch, because when you take a negative to an odd, it switches sign. So we have negative x to the 5th, minus 3x to the 4th, plus x to the 3rd, plus 11x squared, plus 12x, plus, gosh. Here we go. Turn red. There you go. All right, how many sign changes? 1, so we have 1 negative real. And you can't go down by a factor of 2, so you're guaranteed that there is 1 negative. Now, your assignment yesterday said, then try to determine how many total real solutions. You don't have to do that in your assignment from yesterday if you're getting confused, but this is all it means. If there's 4 positive and 1 negative, that would make 5. So you either have 5 real, 3 real, or 1 real. That's all that means. That's all that means. So therefore, I either have 0 complex, 2 complex, or 4 complex. And that's what we're going to get to tomorrow. So this is what we have. Okay, our choices. Because this doesn't factor that I'm aware of. So therefore, I'm going to look at my choices. What are my P's? 1, 2, and 4, my Q's. So my choices are plus or minus 1, plus or minus 2, and plus or minus 4. 1 is a great choice. So let's plug in 1. 1 minus 3, negative 2, minus 1, negative 4, plus 11, 7. What? What happened here? I'm sorry. 1 minus 3 is negative 2, minus 1 is negative 3, plus 11 is 8, minus 12 is negative 4, plus 4 is 0. So x minus 1 is a factor. Let's divide it out. I drop down the first number. 1 times 1 is add negative 2. Good, it divides evenly. Are all these signs positive? No. Do they all alternate? No, so we don't know if one is an upper bound or a lower bound. So that bound part doesn't really play a role here. Okay, so we get to try again. Is it possible one could work again? It is. So if we have x to the fourth minus 2x to the third minus 3x squared plus 8x minus 4, we could plug in 1 and see what we get again. It's possible 1 could be a double root, be a triple root, who knows? 1 minus 2 is negative 1, minus 3 is negative 4, plus 8 is 4, minus 4 is 0. So x minus 1 works again. As soon as you feel like it's a lot of work, just remember that, we could be doing long division. Okay? Okay, now I have a third degree, so I got to start again from the beginning of the process. Remember, the first question I ask in the process is, does it factor? Does it factor? It does. So some people continue to use the rational roots theorem at this point, and that's fine. If you want to plug in 1 again, go ahead. But the fact is you can factor this. It's factorable by grouping. So I take out an x squared, I'm left with an x minus 1. What do I take out in the next part? Negative 4, I'm left with x minus 1. So therefore I have x minus 1 times x squared minus 4. Does the x squared minus 4 factor? Factors to x plus 2 and x minus 2. And what were our previous? So we have x minus 1 to the third. So it turns out that previous polynomial at the very top, it does factor. It factors to x minus 1 cubed times x plus 2 times x minus 2. So you see all 5 factors there, a triple root of 1, and then positive 2 and negative 2. So my solutions are, so I'm going to list the 1 3 times, as you said, plus or minus 2. I want you to be sure that when you list it, that you list all 3 if there's a triple root. You have 2 options, 3 options. You can either write 1 3 times, or you can say 1 triple root, or you can say 1, you can write multiplicity of 3. So those are your options, and usually people just like to write 1 3 times. Sure. Give me some indication that there is a triple root. That would be great. Finally, I'm going to sketch this graph. Say fifth degree, is it positive or negative? So it ends up, that means it starts down. It crosses through negative 2, crosses through 1, crosses through 2, and it has a triple root at 1. Single root at the other spots. So as I graph it, it's going to look something like that. And again, after just 5 minutes, I think it's pretty cool that we're able to find all the solutions, be able to come up with a very good idea of what the graph looks like. That's a pretty complicated graph. Good? Okay, so that wraps up from yesterday. Today, we want to do complex numbers. This is going to go pretty quick because some of it's review. You guys will, these are the easy points on the test, okay? So you want to get today's lesson very well. Square root of negative 1, I squared, negative 1. We are defining those. If you ask why that's the case, pretty difficult question to answer until you really understand the fundamental theorem of algebra. And I'll just tell you like this. If the degree of the polynomial is 5, how many solutions are there? But not all of them have to be real. And in order for the fundamental theorem of algebra to work out, we have to account for the fact that there may be complex solutions. That's where the idea of complex analysis and imaginary numbers come from. We want to be able to perform operations on imaginary numbers. And in the end, we will always write the answer as a plus bi. A plus bi is a complex number because it has two parts. It has a real part, a, and has an imaginary part, b. When we want to subtract them or add them, we simply combine like terms. So we have 4 plus 3i minus 6 plus 8i. So what's the real part going to be? Negative 2, and the imaginary part, 11i. That's it. You do the next one. You get negative 2 plus 3i. There you go. All I have to do is combine like terms. You have a real part, imaginary part. Easy so far? Okay, let's multiply them. 4 times 7 is 28, and I times I is I squared. What is I squared? So therefore, you now have 28 times negative 1, which is negative 28. Three I times negative 8i would be negative 24 I squared. And because I squared is negative 1, we can switch the sign, positive 24. Negative 2i times negative I would be positive 2I squared. I squared is negative 1, negative 2. Try the next one on your own. Instead of writing as I cubed, I wrote as I squared times I, because I know what I squared is. I squared is negative 1. So I end up with a negative 12i. Any questions on that one? Right here? Because a negative times a negative will give me a positive. So I have 6 times negative 1 times negative 2 is a positive 12. And then I times I is I squared, and then I attach the other I over here. So because I had two negatives, I wrote it as a positive. Negative I to the third. So would you agree that that would be like negative I times I squared? Same thing, right? What's I squared? That's negative I times negative 1, which is I. And these don't go away, folks. Second semester with trigonometry, it's very important that we can deal with imaginary numbers like this, okay? So they come up a lot. I to 122nd. Ooh, boy. I to the 1. I to the 2. I to the third is the same thing as I squared times I, right? It'll be a negative I. I to the fourth is the same thing as I squared times I squared, which is 1. I to the fifth would be I times I to the fourth, right? So I times I to the fourth is I. You get the same thing as that, right? And the pattern will continue. I see some good news here. It looks like if the exponent is divisible by 4, the answer is 1. So therefore, I need to find an exponent near 122 that is divisible by 4. What is a number close to 122 that's divisible by 4? 120. So that means that I, to the 120th power, is equal to 1. So I to the 121st is I, and I to the 122nd is -1. All is a cycle of 4, so kind of find the pattern and go with it. The common mistake that people make is some people said the answer is -1 because this is an even number. Well, that's not true because 4 is even and the answer is +1. So, you got to be able to figure it out. Again, it's about being divisible by 4. So, I guess you got a 50-50 chance of guessing right if you say it's even, but about it. So, all right, flip it over. A couple more. Multiply. We will distribute 3i times 2, 6i, minus 15i squared. What is 15i squared? It'll end up being positive 15 because I have a negative 15 and the I squared will be a -1. So I have a positive 15 and a positive 6i. What do I do with the next one? FOIL, 2 times 2, 4, 2 times I, 2i, -2i, and negative I squared. What happens to the middles? Y. What's the relationship between 2 minus I and 2 plus I? So if you remember, about a month ago, as to Spanish. They're conjugates. Very good. So if two binomials are conjugates, you can see that the middles will always cancel. So do you remember when we talked about conjugates? We will use conjugates today in order to simplify imaginary expressions. So I end up with 4 plus negative I squared. What is negative I squared? 1. So you get 4 plus 1 is 5. So it turns out that 2 minus I times 2 plus I is 5. So next time I ask you to give me factors of 5, you're just thinking 1 and 5, right? Well, now you got to list 2 minus I and 2 plus I along with it. Oh, I'm kidding. All right. 6 plus I and 6 minus, or 3 minus 7I. You do this on your own. Go. You see if you can do this. Okay. I got a 25 minus 39I. What do you think? Okay. Now, again, it's important to write it in the form of A plus BI. Okay, so that way we have a number in front of I. And I think that your book's consistent like that. Hopefully it is. But the last thing we want to do is divide. And you don't want to leave an imaginary uh, expression or number in the denominator. And so therefore we need to get rid of it. How do you think we get rid of I in the denominator? I over I, because I over I is 1. I for an I, good. You guys are very clever. I mean, I'm just going to give Princeton and Harvard a call and tell them to come scope my classroom. So, yep. And then I times I is -1. So you end up with negative 4I. So 4 divided by I is negative 4I. Negative 3 over 2I. To multiply top and bottom by. Don't even need to multiply by 2. You can just do I. That will be enough to get rid of it. In negative 3I over 2I squared. What will 2I squared come out to be? We got negative 3I over negative 2. And the negatives will cancel. And you can either write your answer like that or like that. You'll see oftentimes in books, they leave the I right off to the side of the fraction so that you can, again, identify the real part and the imaginary part. Okay, last two. This is a little bit more difficult because I have a 1 in the denominator as well. Yep, you could write it like that. Um, how do you suppose I get rid of this? I minus 1. Yep. We're going to multiply by the conjugate. As I distribute, 3 times I is 3I. 3 times -1 is -3. Over, when I multiply by the conjugate, the reason why you're multiplying by the conjugate is so that the middles will cancel. So if we multiply I by I, we get, yep, I squared or -1. And I don't have to do negative I and positive I. I know that those will go away. So I do 1 times -1 is -1. So we get -3 plus 3I over -2. I will accept that as an answer. However, don't be surprised if your book or myself write it like this. -3 over -2 is 3 halves, and 3I over -2 would be a minus 3 halves I. So either one of these is acceptable. Every once in a while, somebody will get angry at me. They'll be like, well, I don't like it when you write it like that. Don't take the course. It's like some people think that there's a specially designed course just for them. Like, you know what I mean? I just want to be in Happy Land when I do that. Sorry. Good luck. All right. Okay, 2 minus I over 5 plus 2I. Again, multiply by the conjugate. This was a little bit more involved. That was nice. Wow. Look at, see, you passed it on. Now Jack's doing it. Okay. Yep, there was Darren. Darren just did it. Yep, yawn. Looking around. Who's got the disease now? Claire's fighting it. Okay, on the count of 3, everybody just do it. 1, 2, 3. Okay, we got it out. All right. 2 times 5 is 10. 2 times -2I is -4I. Negative I times 5 is -5I. Negative I times -2I is positive 2I squared. I'll often write the I squared just to make sure I don't make a mistake. A lot of people sometimes in this portion, they might write a minus 2I squared or something. Helps me from making mistakes. 5 times 5 is 25. Do I have to multiply the middles? No, because they go away. That's the whole point of multiplying by the conjugate. But you do have a positive 2I and a negative 2I multiplied together, which make a negative 4I squared. So I have 10. I have a minus 9I. What is 2I squared? minus 2 over, this is 24 minus 4i squared. What's 4i squared? Minus 4i squared would be a positive 4, so I get 29. Or 8 minus 9i over 29. I'll accept that answer, or you can write 8 over 29 minus 9 over 29i. Either one is acceptable. Yeah, we try to move pretty quick through here because it's so connected, and as long as you stay on top of your homework, we can get a lot of good scores in this test. So your assignment is page 298, numbers 11 through 45 odd. As you're writing down the assignment, when you check your answers to this section, I want you to know that because humans put the book together, there's error involved. And so therefore, the back of the book regarding this section, I think that there's actually 2 mistakes. Um, so just be aware of that. I think it's problem 19. I just can't remember. 15, I can't. But I, well, that's why the books have, what is this, the 4th edition? That's why you have a 5th edition. They fix the mistakes. And the answer keys, you got college students that make the answer keys to these books that sit up late at night drinking Mountain Dew and cramming for tests and quick try to get a few extra bucks by making answer keys. They make mistakes. It's the way it goes. So, back of the book has a couple of wrong answers. Folks, I gave you 11 through 45, but don't do this. Don't just write down the answer. Show your work. Your last homework you handed in didn't have a lot of work shown for some of you guys. So make sure you're showing your work. Go.